In this first slide, we just sort of introduced the idea of solving inequalities, and I want you to remember to always focus on whether you're dividing or multiplying by a negative number in an inequality, because remember that's the new fatal error that we have due to this section. So be careful in that step of any solving of an inequality. We went on to solve a couple of linear inequalities, and in class we did this one a certain way, so we'll do it a different way. This time I'm going to put all the variable terms to the left-hand side, so that's going to give negative 3x plus 11 is less than or equal to 8. And now I'm going to put the 11 on the other side, so negative 3x is less than or equal to negative 3. Now I'm going to divide by negative 3, and since negative 3 is a negative number, I have to reverse the inequality symbol. And when I divide the left-hand side by negative 3, I get x. And when I divide the right-hand side by negative 3, I get 1. And so I get the solution x is greater than or equal to 1. And remember when we graphed that one, x is greater than or equal to 1, so 1 is the smallest number, and we go out to infinity. So that's the integral notation I meant to say. This one is a compound inequality. It's actually two inequalities in one, but we don't split it up into two separate ones. We can just solve it quickly this way. So we went through that, remember. Just add 5 straight across. 7 and 5 is 12, and negative 1 and 5 is 4. And now divide by 2. 2 is positive, so the inequalities stay the same. 4 divided by 2 is 2. 12 divided by 2 is 6. So the interval notation here is open interval from 2 to 6. And then we solved a few nonlinear inequalities. I know we did this first one in class together. Remember that one was easily factorable, and when we factored it, we got, what did we get? We got x, a minus and a plus, and 6 times 3, like that. So that means that our critical values are 6 and negative 3. So we arrange them on the number line in order. There's negative 3, and there's 6. We write our factors on the side to keep track of what we're doing. And now we determine the sign of each factor. For x minus 6, we look both sides of 6. A number greater than 6 will make x minus 6 positive. A number less than 6 will make x minus 6 negative. So note the two negative signs because I have those two intervals. For x plus 3, negative 3 is the dividing number, and if you have a number greater than negative 3, x plus 3 is positive. So in those two intervals, x plus 3 will be positive, but less than negative 3, and your number will be negative, your x plus 3. So now we know the signs of the factors. So the product will be a negative times a negative, and that'll be a positive for numbers less than negative 3. It's a negative times a positive, which will be a negative for numbers between negative 3 and 6. And it's a positive times a positive, so it's a positive for numbers greater than 6. So we look at the original inequality. It was less than, so that means we want the negatives. So it's that. So the interval is the numbers between negative 3 and 6, and we're going to include those because negative 3 and 6 satisfy the equality part of this. And so now our solution interval is the closed interval from negative 3 to 6. This next one we will first put in standard form, so we get 2x squared plus x minus 1 is greater than or equal to 0. Now we factor. We hope we can factor. Makes it easy. So we've got 2x and x. We've got a plus and a minus, and I want to get a plus, so I'll put the plus here and the minus there. That'll give me the correct middle term, so I get the critical values 1/2 and negative 1. So I ordered them on the number line. Here's negative 1, here's 1/2. The factors are 2x plus 1 and x plus 1. These are my three intervals. So if I have a number greater than 1/2, 2x plus 1 will be positive. If I have a number less than 1/2, 2x, oh, it's 2x minus 1. Sorry. I knew there was something wrong. It wasn't making any sense. There we go. So greater than a half, 2x minus 1 is positive, less than a half, 2x minus 1 is negative. Greater than negative 1, x plus 1 is positive, less than negative 1 is negative. And so my signs are plus for the product, negative for the product, plus for the product. I want greater than or equal to 0, so that means I want the two positives, which are separate intervals. So I'm going to express it as the union of two intervals. So we're going from negative infinity up to negative 1, and we are including the endpoint, negative 1, because that's the number that satisfies the equality part of my inequality union, starting with 1/2, and again I include 1/2 because that also satisfies the equality part, 1/2 to infinity. There were a couple of others. I know we did this one, it just took a little extra time, so I'm not going to rework it here. And we did this one, and again, it's just a little extra time, so I'm not going to rework that one here. So we did do we did this graphing one right here. You can do this one, but actually I would recommend that you omit this one because the graph is not really clear on the TI calculator, so I would say just omit that one. So let's see what those are. The first one is the car rental cost. So we have two plans for renting a car. Plan A is $30 a day, 10 cents a mile. Plan B is $50 a day with free unlimited mileage. And we want to know the range of miles where we will have saving money if we use Plan B. So let's think about this. The cost for Plan A is going to be 30 times the number of days. Let's let D be the number of days. D is the number of days. Okay. But we also have to add 10 cents per mile, since that's got to be in dollars, because that 30 is in dollars. So that's 0.1, let's say M, where M is the number of miles. So I like to identify my variables and let everybody know what they stand for. So that's the cost for A. The cost for B, using those same variables, is, let's see, B is $50 per day, and it's really 0 for miles because the miles are free. So we want to know something about the range of miles. Okay, so we're going to take these two expressions, and we want to know Plan B is going to save money, so that means Plan B has to cost less than Plan A cost. Well, the Plan B cost is $50, 50D, and the Plan A cost is 30D plus 0.1 M. Okay, so let's solve this for M. See what we get. So the 30D can go over there, and we end up with, let's come back up here, we end up with 20D is less than 0.1 M. So we continue solving by dividing by 0.1. 20 divided by 0.1 is 200. 200D less than M. Okay, so that 200 is $200. So that means that if we well, actually that 200 is, I don't know, it's just, I don't know what it is, but if we divide by D, we get 200 is less than M over D, and M over D is miles per day. So that means that if we drive, this is what I was trying to say, if we drive more than 200 miles per day, miles per day, Plan B will cost less than Plan A. And the reason we know that is because miles per day has to be greater than 200. So as long as you drive more than 200 miles per day, Plan B will cost less. The other problem has to do with the relationship between Celsius and Fahrenheit using the example 8 relationship between Celsius and Fahrenheit, and I don't remember that by heart right now. I kind of remember it, but I don't remember it exactly, so I'm not going to do this one for you, but all you have to do is go to example 8 And what they tell you C is, they'll say C is equal to some fraction times something minus 32. I think it's Fahrenheit minus 32, and I think it's 5/9. I think that's what it is. But let's just put a question mark there. So all you have to do is take this expression for C and put it right there, and then just solve for F. So whatever the expression is, I think it's that, but I'm not sure. Pretty sure that's what it is. Whatever, whatever it is, though, put it right here in this inequality. And so you have 20 is less than or equal to whatever that formula is less than or equal to 30. And then you just solve for F. So work on that one and see what you get for the range of the range on Fahrenheit. That's the same as between 20 and 30 on Celsius.